The 20th century opened its eyes to a world trembling on the edge of a scientific transformation. The grand clockwork vision of Isaac Newton had reigned supreme for over 2 centuries. Every motion, every star, every atom was believed to follow precise laws, a divine machinery ticking in perfect rhythm. The universe, as classical physics had described it, was a predictable, measurable, and orderly place. Scientists believed that if one could know all the forces and all the positions of all particles at one moment, the future and past of the universe could be calculated like the gears of a cosmic clock. Certainty was the soul of science. But nature was about to whisper a different truth, one that would unsettle even the most brilliant minds. It began quietly, in the laboratories of the late 19th century, when experiments started showing cracks in the old worldview. Light, which had always been thought of as a continuous wave, began to behave strangely. It seemed to arrive in packets, quanta, as if it carried both the soul of a wave and the identity of a particle. The laws that once governed motion failed to describe the behavior of the tiniest fragments of matter. Energy was no longer smooth and continuous. It came in jumps, in discrete bursts that defied the logic of Newton's equations. This was the dawn of quantum mechanics, a revolution that would not just change science, but shake the very concept of reality itself. In this storm of confusion and discovery emerged a young German physicist whose mind was as restless as the atoms he sought to understand, Werner Heisenberg. Heisenberg was born in 1901 in Würzburg, Germany, a world still rooted in classical certainty, but on the verge of an intellectual earthquake. As a child, he was fascinated by mathematics and music. The precision of numbers and the harmony of sound mirrored his inner search for beauty and order. Yet, destiny was preparing him for a world where order would crumble into uncertainty and knowledge itself would transform into probability. His mind was sharp, intuitive, and unafraid to question authority. He belonged to a generation that would rebuild the laws of physics from the ground up. When Heisenberg entered the world of academia, quantum puzzles had already begun to haunt the scientific community. Max Planck had introduced the idea of energy quanta in 1900, suggesting that light was emitted and absorbed in discrete packets. Einstein had taken this further by describing light as composed of photons, tiny quanta of energy that could knock electrons off metal surfaces. These ideas worked mathematically but felt alien to intuition. The giants of physics, men like Bohr, Einstein, and Schrödinger, struggled to make sense of this new realm where matter behaved like waves and particles at the same time. The world of the very small, the atomic world, refused to play by the rules of the large. Every time scientists tried to measure, something unexpected happened. Electrons did not orbit the nucleus like planets around the sun as classical models suggested. Instead, they appeared to jump unpredictably between energy levels, emitting light in mysterious patterns that no known equation could predict with certainty. Something profound was missing in human understanding, and the search for that missing truth would bring Heisenberg into history's spotlight. By his early 20s, Heisenberg found himself working under Niels Bohr in Copenhagen. Bohr's institute was the beating heart of the new physics, a place where old assumptions were challenged and bold ideas were born. Bohr believed that the atom could not be understood using the language of classical physics. The observer, he said, was part of the experiment. The act of measurement itself influenced what was being measured. To Heisenberg, this was both fascinating and troubling. He was searching for mathematical clarity in a world that seemed increasingly filled with paradoxes. In the summer of 1925, suffering from severe hay fever, Heisenberg retreated to the tiny island of Helgoland in the North Sea to recover. There, isolated from distractions, he began to see the problem differently. He stopped trying to imagine what electrons looked like or how they moved in space. Instead, he focused purely on what could be measured, the frequencies and intensities of the light they emitted. He replaced the old picture of orbits with abstract numbers representing transitions between energy states. In that moment, He let go of the need to visualize the invisible. What emerged from that lonely island was a bold new mathematical framework, matrix mechanics. The first complete version of quantum mechanics. It was radical. It did not describe particles as tiny billiard balls or waves flowing through space. It described only relationships between measurable quantities, avoiding the temptation to imagine the unseeable. To many physicists, it felt as though Heisenberg had stripped away the comfort of reality itself. But it worked. His equations could predict the spectral lines of hydrogen and other atoms with astonishing accuracy. The universe, once thought to be a simple machine, was now revealed as a symphony of probabilities. Heisenberg's revolutionary insight was that nature does not exist as a fixed reality independent of observation. Instead, it exists as a cloud of potentialities that collapse into a specific state only when observed. The physical world was no longer an objective stage on which events unfolded. It was an interaction, a dance between the observer and the observed. This was the beginning of a new kind of physics, one that would forever divide scientific philosophy. As Heisenberg's ideas spread, the old generation of physicists struggled to accept them. Einstein, the very man who had helped start the quantum revolution, could not embrace its uncertainty. Heisenberg, on the other hand, leaned into it. He realized that uncertainty was not a flaw in measurement, but a fundamental feature of the universe. When he later formulated his famous uncertainty principle, it was the logical conclusion of what began on Helgoland, that one could never simultaneously know a particle's position and momentum with perfect accuracy. The more precisely one was known, the less precisely the other could be determined. This realization was not just mathematical, it was philosophical. It meant that the universe itself was not a rigid machine, but a realm governed by chance and indeterminacy. For centuries, scientists had sought to eliminate uncertainty from knowledge. Heisenberg instead revealed that uncertainty is woven into the very fabric of existence. The deterministic universe of Newton gave way to a quantum universe alive with possibilities, one where particles could exist in multiple states until measured, where outcomes could only be predicted by probability, not certainty. To understand how revolutionary this was, one must imagine the intellectual courage it took to break from centuries of belief. Every instinct of science had been built on the conviction that with better tools, better data, and more precise equations, one could uncover complete truth. But Heisenberg's work declared that even perfect knowledge has limits, that nature itself draws a line beyond which the human mind cannot see. This was not a defeat for science, but its evolution. Quantum mechanics, born from Heisenberg's radical thinking, soon became a collaborative triumph. Schrödinger introduced his wave equation, complementing Heisenberg's matrix formulation. Bohr added the principle of complementarity, explaining that wave and particle behaviors are two sides of the same coin. Together, they built a new architecture of thought that explained everything from atomic structure to radiation, and eventually paved the way for the technologies that define modern life, from semiconductors and lasers to quantum computers. Yet behind every formula was the ghost of uncertainty, the strange reminder that reality is not what it seems. For Heisenberg, this was not something to fear but to embrace. He saw beauty in the limits of knowledge. To him, uncertainty was not chaos. It was the universe's way of reminding humanity of its place in the grand design. His scientific vision carried a quiet humility, that even in the age of reason, there would always remain mystery. The rise of quantum mechanics was not just a story of equations, it was a human story, one of courage, imagination, and the willingness to let go of certainty. Heisenberg's journey mirrored that transformation. From the ordered comfort of classical thinking, he ventured into the unknown and returned with a truth that redefined the meaning of knowledge itself. His work did not simply explain the atom, it changed the way humankind understands reality. When Heisenberg first presented his quantum theory to his peers, many were stunned by its abstraction. Even Max Born and Pascal Jordan, who helped refine his mathematics, realized they were dealing with something that transcended human intuition. The old world of visualization, of picturing particles moving along clear paths, was gone. The new world was invisible, mathematical, probabilistic, and beautifully strange. It was a universe that could only be described through relationships, not certainties. Heisenberg's rise within the scientific community was meteoric. By 1932, he had received the Nobel Prize in Physics for the creation of quantum mechanics, recognizing his monumental role in shaping modern physics. But beyond the recognition, what defined Heisenberg's legacy was his audacity to question the very foundation of knowledge. His equations became the language of a new era, one that replaced determinism with possibility and certainty with wonder. As the story of quantum mechanics unfolded, Heisenberg stood as one of its most fearless architects. His work represented the bridge between two worlds, the solid, predictable universe of classical science and the fluid, uncertain world of the quantum. It was not a comfortable bridge to cross, even for him. There were moments of doubt, sleepless nights, and philosophical battles that would last his entire life. But his resolve never wavered. He believed that truth, even if uncertain, was still truth, and that embracing it brought humanity closer to the heart of existence. In the great arc of human discovery, few moments rival the birth of quantum mechanics. It was not just a shift in theory, it was a transformation of thought itself. Heisenberg's role in that transformation was not merely that of a scientist, but of a pioneer who redefined the limits of knowledge. His name became synonymous with uncertainty, yet his contribution brought clarity to the chaos of the atomic world. In making certainty impossible, Heisenberg had revealed a deeper certainty, that the universe is alive with mystery, and that understanding it requires both intellect and imagination. As the echoes of Heisenberg's discovery rippled through the scientific world, the very definition of reality began to blur. The solid universe of objects and motions was dissolving into patterns of probability, and with every equation written, the old certainties of science faded a little more. Physicists found themselves staring into a new kind of truth, one that was statistical, unpredictable, and profoundly strange. In this new world, the smallest particles could no longer be said to have definite paths or positions until they were observed. Reality, it seemed, was woven not from things but from possibilities. For Heisenberg, this realization was both exhilarating and deeply humbling. He often spoke of standing before nature as a listener before music, sensing meaning in rhythm and harmony rather than in tangible form. His mathematical symbols had uncovered a hidden melody in the universe, but it was one that could never be fully written down. The notes changed the moment they were heard. He knew that the equations were not just descriptions of motion, but reflections of a mysterious dialogue between the observer and the observed, between mind and matter. By the mid-1920s, this new understanding of the micro-world was spreading rapidly. Schrödinger's wave mechanics had entered the scene, offering another way to express the same strange truths. Initially, Schrödinger and Heisenberg seemed to represent opposite sides of the quantum debate: waves versus matrices, visualization versus abstraction. But when the mathematics was compared, the two theories proved to be equivalent, two languages describing the same hidden reality. Together they formed the foundation of quantum mechanics, a structure so powerful that it could predict atomic behavior with unmatched precision. Still, even among its creators, quantum theory provoked philosophical unease. The old dream of absolute knowledge had been replaced by a new rulebook written in probabilities. Einstein protested, unwilling to accept that God played dice. Bohr, Heisenberg's mentor, countered with the idea that nature was not playing dice at all. It was simply that humans could not ask nature for more information than it could give. Heisenberg stood firmly beside Bohr. He understood that measurement was not neutral, the act of observing changed the outcome. Reality, therefore, was participatory. To see was to influence. To measure was to interfere. This view unsettled many who longed for the comfort of an independent, objective universe. But Heisenberg had come to peace with it. He believed that knowledge must always carry humility, that science, at its purest, acknowledges its own limits. His uncertainty principle, published in 1927, captured this philosophy in precise mathematical form. It stated that the more accurately one determines a particle's position, the less precisely its momentum can be known, and vice versa. This was not a flaw of instruments but a fundamental feature of reality itself. Nature imposed a barrier that no experiment could cross. The implications were staggering. It meant that the universe could never be entirely predictable. Even if one knew all the equations, the future could not be determined exactly. What had been thought of as randomness was not ignorance but essence. The electron was not a point moving along a line but a haze of probabilities, existing in many potential states until measurement forced it into one. This was a world where cause and effect were replaced by likelihood and uncertainty. A world both frightening and beautiful. In those years, Heisenberg became one of the leading voices of this new quantum generation. He lectured across Europe, explaining that uncertainty did not destroy science, it redefined it. The purpose of physics was not to expose a hidden machinery, but to describe the harmony that arises from interaction. His words carried a quiet conviction that inspired younger scientists. They felt the weight of history shifting in their hands. Yet, beyond the lecture halls, the world itself was changing. Europe in the 1930s was a continent drifting toward darkness. Political unrest, economic depression, and the rise of extremist ideologies began to overshadow the bright light of intellectual progress. In Germany, where Heisenberg had become a professor at Leipzig, the Nazi regime sought to control every aspect of cultural and scientific life. Many of Heisenberg's Jewish colleagues and mentors, including some of the very architects of quantum theory, were dismissed, exiled, or worse. Heisenberg found himself in a moral labyrinth. His love for science was pure, but the environment around him had grown poisonous. Accused by Nazi ideologues of teaching Jewish physics, a slur aimed at relativity and quantum theory, he was investigated and threatened. Only the intervention of high-ranking officials who recognized his value saved him from imprisonment or exile. Through these trials, Heisenberg remained devoted to his research, though his conscience was heavy with the weight of the times. During the Second World War, Heisenberg was appointed to lead Germany's nuclear research project. Whether he sought to build an atomic bomb or to prevent one remains a question historians still debate. Some evidence suggests that he deliberately slowed the project, steering it toward energy production rather than weaponization. Others believe he simply miscalculated the feasibility. What is certain is that the war years tested his integrity and his belief that science should serve humanity, not destroy it. The young man who had once made certainty impossible now faced the moral uncertainty of survival itself. When the war ended, Heisenberg was captured by Allied forces and held with other German scientists at Farm Hall in England. There, under secret surveillance, their conversations were recorded. When news reached them of the atomic bombing of Hiroshima, the transcripts reveal shock, sorrow, and a deep sense of loss. Heisenberg's reaction was philosophical. He realized that the age of innocence for physics was over. The discoveries meant to illuminate nature had been turned into tools of destruction. From that moment, he dedicated much of his later life to promoting peaceful science and international collaboration. After his release, Heisenberg returned to Germany determined to rebuild its scientific spirit. In a nation shattered by war, he became a voice for reconciliation, helping to re-establish the Max Planck Society and guiding a new generation of physicists. His lectures drew students not only for their intellectual brilliance, but for their moral depth. He spoke of uncertainty not as despair, but as wisdom, the understanding that knowledge must be tempered with responsibility. He reminded his listeners that physics was not only about discovering what the world is, but also about deciding what kind of world humanity should build with that knowledge. In the post-war decades, quantum mechanics blossomed into the foundation of modern technology, Transistors, lasers, magnetic resonance imaging, quantum chemistry, all were born from the principles Heisenberg had helped uncover. He lived to see his abstract equations translated into machines that could compute, communicate, and heal. The world had entered the atomic age, guided by the same quantum laws that once seemed like abstract mathematics scribbled on a lonely island. But amid these triumphs, Heisenberg continued to reflect on the philosophical meaning of what he had started. He saw quantum theory not only as a tool for technology, but as a mirror reflecting the limits of human thought. He often said that the act of observation was not just a physical event, but a meeting point between consciousness and nature. To understand the universe, one must also understand oneself. This idea blurred the boundaries between physics and philosophy, drawing Heisenberg into dialogues with thinkers, theologians, and artists. He believed that science and spirituality were not enemies but partners in the search for truth. Heisenberg's writings from this period reveal a man who had come to terms with paradox. He no longer sought certainty, instead, he sought harmony between opposites. In his eyes, uncertainty was a symbol of freedom, proof that the universe was not a rigid machine, but a living, creative process. He saw beauty in the way quantum mechanics allowed multiple possibilities to coexist until an observation brought one into being. It was, in a sense, a poetic universe, alive with potential. His reflections extended beyond physics. He began to explore how the principles of uncertainty could influence human thinking, ethics, and culture. He argued that rigid ideologies, political or religious, were dangerous precisely because they denied uncertainty. Just as the quantum world requires flexibility and openness, so too does human society. True wisdom, he believed, lies in accepting that knowledge is never complete and that humility must accompany power. As Heisenberg grew older, he watched the new generation of physicists push the boundaries of the quantum world even further. Quantum field theory, particle accelerators, and eventually quantum electrodynamics all built upon the foundation he helped create. Yet he never lost the wonder that had driven him from the start. When asked late in life what he saw as the most important result of his work, he smiled and said, "It is that we have learned that the world is not as we thought, and that we must learn to think anew." A Heisenberg story, in the end, is not merely the biography of a scientist. It is the journey of human thought itself, from the illusion of certainty to the acceptance of mystery. His life embodied the courage to let go of old truths and to face the unknown with curiosity rather than fear. The uncertainty principle, far from being a limitation, became a symbol of intellectual freedom, the recognition that the universe is deeper, subtler, and more beautiful than any single equation can express. As the 20th century moved toward its close, the legacy of quantum mechanics expanded beyond physics. Philosophers, artists, and even poets found inspiration in its ideas. The concept that observation shapes reality influenced everything from psychology to literature. In science, the exploration of quantum entanglement and non-locality reopened debates about the nature of space and time, debates that Heisenberg himself had once ignited. His influence reached into cosmology, where physicists began to wonder whether the universe itself emerged from quantum fluctuations. The smallest uncertainty had become the seed of the largest existence. In quiet moments, Heisenberg would recall the night skies of his youth, when he had first wondered about the laws guiding the stars. He had once believed that if one could understand those laws completely, one would know everything. Now, at the end of his journey, he saw it differently. The more he understood, the more he felt the depth of what remained unknown. Knowledge had expanded, but so had mystery. For him, that was not discouragement but grace, a sign that the human quest for understanding would never end. Heisenberg died in 1976, leaving behind not just a body of scientific work, but a philosophy that continues to echo through the halls of both science and thought. The uncertainty he discovered still defines modern physics, shaping the way we build technologies and the way we imagine the universe. His vision lives in every quantum computer, every atomic clock, every experiment that probes the boundaries of the known. But it also lives in a deeper sense, in the idea that humility and wonder are essential companions to knowledge. To tell Heisenberg's story is to tell the story of a mind brave enough to face ambiguity. It is to recognize that science is not about conquering mystery, but about learning to live within it. The rise of quantum mechanics, with Heisenberg at its heart, was not just a scientific event, it was a human awakening. It taught us that truth is not a final destination, but a horizon that moves as we move, always just beyond reach, always calling us forward. When the camera fades in the imagination, one might picture Heisenberg standing once more on the windy cliffs of Helgoland, the sea roaring below, his notebook open to symbols that would change the world. The sky above him is vast, uncertain, filled with stars whose light carries the memory of ancient explosions. He gazes into that infinite mystery, knowing that even the stars obey the laws of uncertainty, that even in their brilliance lies the same dance of chance and possibility that governs every atom. And as the waves crash against the rocks, one can almost hear the whisper of the quantum world, a world that Heisenberg helped reveal, where certainty dissolves and wonder begins. The birth of the uncertainty principle was not a sudden event. It was the result of years of quiet struggle, a slow awakening in the mind of a young physicist who dared to question how deeply humanity could ever know the universe. Werner Heisenberg's name would forever be tied to this revolutionary idea, an idea that would reshape the meaning of knowledge, observation, and reality itself. To understand its birth, one must first imagine the world of science before it, a world where everything seemed clear, precise, and measurable, where certainty was the very foundation of truth. In the age before quantum mechanics, the universe was thought to be a vast machine. If one knew all the forces acting upon every particle, one could, in theory, predict the future and retell the past. This belief, rooted in the classical mechanics of Newton, gave humanity a sense of mastery over nature. It was comforting, logical, and deeply human. A universe of predictable cause and effect. But the dawn of the quantum era shattered that illusion. When scientists began to explore the behavior of atoms and subatomic particles, they encountered a strange realm where certainty melted away and logic twisted into paradox. Werner Heisenberg was at the heart of this revolution. His work on matrix mechanics in 1925 had already broken the boundaries of classical thought. It replaced visual models with mathematical relationships, describing not how particles looked but how they behaved. Yet even within this success, Heisenberg sensed something deeper, an invisible barrier that no amount of mathematics could cross. The equations worked perfectly, but what did they truly describe? Could one ever know both where a particle was and how fast it was moving? Could nature reveal itself entirely, or did it keep something hidden from all observers? These questions began to haunt him. The turning point came not in a laboratory, but in the quiet solitude of thought. Heisenberg was a man who often retreated inward when faced with a problem, walking alone through the night streets of Copenhagen or along the shores of Helgoland, lost in contemplation. He had realized that when one tries to observe the tiniest fragments of nature, the act of observation itself changes what is being observed. To see an electron, one must shine light upon it. But light is made of photons, and when a photon collides with an electron, it transfers energy and changes the electron's motion. Thus, the more precisely one tries to see where the electron is, the more one disturbs its velocity. The more accurately one measures its momentum, the less one can know about its position. In this paradox, Heisenberg found a profound truth, a law of nature that was not about imperfection in instruments, but about the limits built into reality itself. It was not that humanity lacked the right tools, it was that nature refused to allow complete knowledge. This realization became the seed of the uncertainty principle, one of the most revolutionary ideas in the history of science. By 1927, Heisenberg had refined this insight into a precise mathematical relationship, the product of the uncertainty in position, psi, and the uncertainty in momentum, Vought p, could never be smaller than a fixed constant, the reduced Planck's constant $2. This simple inequality carried within it a universe of meaning. It declared that absolute precision was impossible. Nature was not a static reality waiting to be measured. It was an interplay between potential and observation, between what could be known and what must remain unknown. To most physicists of his time, this idea was nothing short of shocking. It meant that the very foundation of scientific inquiry, the belief that observation could reveal objective truth, was no longer valid at the quantum level. The world beneath the microscope was not governed by certainty, but by probability. For Heisenberg, this was not a defeat, but a revelation. The universe was not a cold machine, but a living mystery, filled with patterns of possibility. When he first presented the uncertainty principle, it sparked both admiration and controversy. Niels Bohr immediately recognized its significance, seeing in it the completion of his complementarity principle, the idea that light and matter can behave as both waves and particles, but never simultaneously in the same experiment. Bohr and Heisenberg together wove these concepts into the philosophical fabric of the Copenhagen interpretation, which held that quantum mechanics does not describe an objective reality, but the outcomes of measurements. The act of observation, they argued, was fundamental. Without an observer, the world of the quantum remained a realm of pure potential. Einstein, however, could not accept such a view. To him, the idea that uncertainty was built into nature was intolerable. He famously said, "God does not play dice with the universe." For Einstein, reality had to exist independently of measurement, precise, deterministic, and complete. Heisenberg, on the other hand, believed that Einstein's vision, though beautiful, belonged to an older world. In Heisenberg's universe, God not only played dice but did so with elegance and order, guided by probabilities that revealed a deeper harmony beyond human understanding. The debates between these two giants became legendary. At the Solvay conferences, physicists gathered to discuss the strange new world of quantum theory. Einstein would present thought experiments challenging uncertainty, proposing scenarios meant to expose hidden variables that could restore determinism. But time and again, Bohr and Heisenberg would counter, showing that such variables could not exist without violating the principles of quantum mechanics. Each discussion pushed the boundaries of philosophy and science alike, transforming physics into a meditation on the nature of knowledge itself. Heisenberg's principle also carried a quiet philosophical beauty. It suggested that the observer and the observed were not separate entities, but part of one inseparable system. To measure the universe was to participate in its unfolding. Knowledge was not passive but active, not external but relational. This idea resonated far beyond physics. Philosophers saw in it a reflection of human experience, the notion that perception shapes reality, that truth is not fixed but co-created by observation. In art, literature, and even psychology, echoes of Heisenberg's uncertainty began to appear, influencing thought in unexpected places. But behind this philosophical depth lay an even deeper emotional truth. Heisenberg's principle forced humanity to confront its limits. For centuries, science had been a march toward mastery, each discovery bringing the illusion of total control. The uncertainty principle broke that illusion. It said that no matter how advanced human knowledge becomes, there will always remain an element of mystery, a domain that cannot be penetrated, a veil that cannot be lifted. It was a humbling revelation, reminding scientists that knowledge is not the conquest of truth, but a dialogue with it. Heisenberg himself was deeply aware of this humility. He often spoke of the uncertainty principle, not as a statement of ignorance, but as a statement of balance. It was nature's way of preserving harmony, preventing humanity from ever claiming absolute power over existence. The principle drew a line, not one of weakness, but of wisdom. It told humanity that the universe is not something to be fully owned, but something to be understood with reverence. The philosophical impact of this idea rippled far beyond laboratories. It changed how scientists thought about causality and determinism. In classical physics, every effect had a definite cause, and the future followed inexorably from the past. But Heisenberg's principle showed that, at the quantum level, events do not unfold with certainty. Instead, there exists a range of possible outcomes, each with its own probability. This indeterminacy lies at the heart of creation itself. It means that the future is not predetermined, that there is, even in the cold equations of physics, room for spontaneity, creativity, and perhaps even free will. Philosophers and theologians found in Heisenberg's discovery a bridge between science and metaphysics. Some saw in uncertainty the scientific echo of ancient wisdom, the idea that reality cannot be fully grasped by reason alone. Others interpreted it as proof that consciousness plays an active role in shaping the universe. While Heisenberg himself remained cautious about such interpretations, he did not deny that his work touched on profound questions. He once wrote that what we observe is not nature itself, but nature exposed to our method of questioning. In that statement lies a poetic truth, that science at its core is a conversation between humanity and the cosmos. In the decades that followed, the uncertainty principle became a cornerstone of modern physics. It explained why atoms do not collapse, because their electrons cannot have both a precise position and zero momentum. It underpins the stability of matter, the behavior of semiconductors, the principles of quantum tunneling, and even the structure of stars. Every piece of modern technology, from lasers to quantum computers, owes something to the limits Heisenberg defined. What began as a philosophical realization became the mathematical foundation for the modern world. Yet, even as his principle became universally accepted, Heisenberg continued to wrestle with its meaning. He saw in it not only a scientific law, but a mirror reflecting the human condition. The uncertainty principle was not just about particles, it was about knowledge itself, the eternal tension between what can be known and what must remain mysterious. It reminded him that science, like life, is an endless journey through questions that generate more questions. Certainty may give comfort, but uncertainty gives depth. The young man who had once stared into the abstract world of numbers now found himself staring into the depths of philosophy. He realized that the more science advanced, the more it resembled art, an act of imagination as much as logic, intuition as much as proof. Quantum theory, with its probabilities and paradoxes, was not chaos but a deeper order that defied classical reasoning. The uncertainty principle, in its quiet simplicity, captured the poetry of that truth. It became not just a formula but a worldview, a symbol of how beauty and truth often live in tension, side by side. As Heisenberg's ideas spread, they transformed physics into something more profound than a study of matter. They made it a study of knowledge itself, of how reality reveals itself only through interaction, and how observation is not the end of inquiry, but its beginning. The birth of the uncertainty principle marked a new era, in which science no longer claimed to know everything, but instead embraced the mystery that makes knowing possible. And in that mystery Heisenberg found his peace. The uncertainty principle, once introduced by Heisenberg, began to ripple far beyond the walls of physics laboratories. It was no longer just an equation, it became a philosophical statement about the very limits of human understanding. Physicists, philosophers, and even poets began to interpret it in their own ways. The world that once believed in certainty, in measurable truth and predictable outcomes, now faced a strange new truth: the universe hides as much as it reveals. Every measurement, every observation, carried with it a price. To know one aspect of reality meant to let go of another. It was a humbling realization that knowledge itself was a trade off between what could be seen and what must remain unseen. The scientific community was divided. To some, the principle felt like defeat, a confession that science could never fully uncover the ultimate truth of nature. To others, it was liberation. It opened a new way of thinking, one that embraced complexity, randomness, and mystery. Heisenberg's work gave birth to a fresh understanding. that uncertainty is not a failure of measurement but a property of existence itself. In every atom, every photon, there existed a dance between what is known and what is unknown, between precision and probability. This idea reshaped not only physics but the philosophy of science itself. Heisenberg's uncertainty principle challenged the rigid structure of classical determinism. Before him, the vision of the universe was mechanical. If you knew the position and speed of every particle, you could, in theory, predict the future and reconstruct the past. It was a comforting idea, suggesting that the world was built on logic, that the cosmos was a perfectly balanced machine. But Heisenberg shattered that illusion. His discovery revealed that the universe was not a clockwork device, but a living, breathing mystery, full of spontaneous behavior and hidden variables. The world was not bound by predictable precision. Instead, it pulsed with uncertainty and possibility. This revelation had deep philosophical consequences. It forced humanity to confront the boundaries of perception and the fallibility of the human mind. Heisenberg's idea suggested that the act of observing changes the observed, that the universe does not exist as a static, independent reality, but as a field of potential outcomes that become real only through interaction. In essence, the observer and the observed were now entangled in an eternal relationship. This realization blurred the line between subject and object, between truth and perception. It redefined reality as a partnership between consciousness and the cosmos. Many thinkers of the time found this deeply unsettling. How could the bedrock of physics, once seen as the most objective of sciences, be influenced by the presence of an observer? Einstein, deeply rooted in the belief of an objective universe, could not accept it. He famously said, "God does not play dice with the universe." But Heisenberg, along with Bohr, countered that perhaps God did play dice, and that it was humanity's duty not to dictate the rules, but to understand the probabilities. Their debates were not mere academic arguments, they were philosophical battles that defined the very nature of reality. The Copenhagen interpretation, which Heisenberg helped shape, embraced the idea that nature itself was probabilistic. Nothing was certain until measured, and even then, that certainty was fleeting, an illusion of observation. In universities and research centers, young physicists began to see the world through new eyes. The uncertainty principle was no longer a limitation, but a window into the hidden depths of matter. It inspired generations to think beyond the visible, to explore the invisible fields of quantum behavior. It showed that the smallest particles did not follow the paths of logic, but danced to the rhythm of probability. Heisenberg's work transformed the laboratory into a realm of possibilities, where even a particle's position could exist in multiple states until observed. This defied not only physics, but the human intuition of what was real. As the 20th century progressed, Heisenberg's uncertainty principle found echoes in fields far beyond science. Philosophers drew parallels between quantum uncertainty and the uncertainty of human experience. Psychologists compared the principle to the unpredictability of thought and behavior. Artists and writers embraced it as a metaphor for modern life, an age of ambiguity, flux, and the constant search for meaning in a world that offered no guarantees. Heisenberg's discovery had become more than a scientific theory, it was a mirror reflecting the complexity of existence itself. Even in technology, the uncertainty principle quietly shaped the future. Quantum mechanics, rooted in Heisenberg's work, became the foundation of modern electronics, semiconductors, lasers, and eventually quantum computing, the very devices that define our modern world. Computers, smartphones, and communication networks owe their existence to a principle that began as a statement of limitation. In accepting uncertainty, humanity had unlocked new dimensions of possibility. The paradox of Heisenberg's work was profound. By acknowledging what we cannot know, we discovered how to create. But for Heisenberg himself, the journey was as philosophical as it was scientific. He saw the uncertainty principle not as chaos, but as balance, a deep truth about nature's order. To him, uncertainty was not disorder, it was harmony at a higher level, beyond the grasp of absolute measurement. He often reflected on how human beings crave certainty in a world that is, by its very nature, uncertain. His principle was not a denial of knowledge, but a guide to wisdom, a reminder that truth is layered, delicate, and never final. As he continued his work, Heisenberg found solace in the idea that uncertainty brought beauty to science. Without uncertainty, there would be no creativity, no discovery, no evolution of thought. The unknown was not the enemy of knowledge, but its driving force. He believed that every scientist must learn to live within that space of doubt, to navigate the shadows between knowing and not knowing. For Heisenberg, the uncertainty principle was more than an equation. It was a philosophy of life, a reflection of the mysterious balance between human curiosity and the universe's infinite complexity. Over time, even Einstein's resistance softened, as the evidence became overwhelming. Experiments confirmed Heisenberg's ideas time and again, proving that at the quantum level, the universe truly defied certainty. What once seemed unimaginable became the foundation of reality. Physicists began to see that uncertainty was not merely a technical constraint, it was woven into the fabric of the cosmos. Every atom, every wave of light, every moment of existence was governed by probabilities, not absolutes. As history unfolded, Heisenberg's principle became one of the most profound insights ever gained about the universe. It told a story not just about particles, but about humanity itself. We seek to predict, to control, to measure everything, yet the universe reminds us that there are boundaries to what we can know. And within those boundaries lies the beauty of existence. The uncertainty principle stands as a testament to humility, the acknowledgement that even the brightest minds cannot fully grasp the totality of creation. Werner Heisenberg, in making certainty impossible, gave humanity something far greater wonder. He showed that mystery is not ignorance, but the heartbeat of discovery. Every unanswered question leads to a deeper understanding. Every limitation opens a door to new thought. His principle continues to echo across time, reminding us that truth is not fixed but fluid, that the universe does not yield to certainty, but invites us to explore the infinite landscape of the unknown. Heisenberg's uncertainty principle thus became not just a law of physics, but a law of thought. It reminds every thinker, dreamer, and scientist that to seek knowledge is to accept imperfection, to embrace the dance of possibilities that defines life itself. In the delicate balance between knowing and not knowing lies the essence of human progress. The man who made certainty impossible did not close a chapter in science. He opened an endless book, one whose pages continue to be written every time we look deeper into the mysteries of the cosmos. Werner Heisenberg's journey began in the soft light of early 20th century Germany, a world balanced between tradition and transformation. The year was 1901 and Europe was pulsing with invention, discovery, and the rise of modern science. In the quiet Bavarian city of Würzburg, a child was born who would one day redefine the limits of human understanding. The world into which young Heisenberg opened his eyes was one of structure, order, and precision, qualities that would become both his compass and his challenge. His father, August Heisenberg, was a respected scholar of Greek philology, a man of letters and intellect. His mother, Annie Wecklein, came from a cultured family connected to education and the humanities. From his earliest days, Werner lived in a house where ideas were not just taught, they were breathed. As a child, he showed a remarkable curiosity, an insatiable need to understand how things worked. The world fascinated him, the movement of the stars, the patterns of music, the mathematical rhythm hidden in nature. He was known to take apart mechanical toys, not out of mischief, but out of a deep desire to see the invisible mechanism that gave them life. This curiosity was the earliest spark of the mind that would later challenge the certainty of all mechanisms. His teachers noticed his extraordinary grasp of mathematics and physics, but what made him stand apart was not just intellect. It was intuition. Even at a young age, Heisenberg had a way of seeing through complexity, of understanding the shape of a problem beyond its numbers. In school, He was disciplined but not conventional. He excelled in geometry and algebra, yet often grew restless with routine exercises. His imagination demanded challenge. He would ponder questions that seemed abstract for a boy his age. What lies beneath the surface of things? Can motion itself be described completely by equations? His fascination with numbers merged with a deep philosophical instinct. He didn't merely calculate, he contemplated. The influence of his father's classical scholarship also gave him a sense of balance between reason and beauty, between the rigor of science and the spirit of philosophy. That duality would follow him all his life, shaping the way he saw not only physics but existence itself. Heisenberg's early education coincided with the years of upheaval in Germany. The First World War was brewing in the distance, and the world of science was both a sanctuary and a storm. As a teenager, he studied at the Maximilian Gymnasium in Munich, a school known for its academic excellence. There he found mentors who recognized his gift for mathematics and physics. But the turbulence of his era reached even the classroom. During the war, food was scarce, resources limited, and many of his classmates were drafted or lost. Young Werner remained focused, escaping into the realm of numbers and theory, where the world's chaos could be replaced by structure and harmony. In those moments, the universe seemed pure and untouched by human conflict. When the war ended, Germany was in ruins, its people struggling with defeat, poverty, and disillusionment. The young Heisenberg, barely out of adolescence, saw a nation searching for direction. Yet within him burned a belief that knowledge could rebuild what war had destroyed. He sought not politics, but truth, the kind that lay beneath the surface of the physical world. In 1920, he entered the University of Munich, one of Europe's centers of scientific excellence. There he came under the guidance of Arnold Sommerfeld, one of the most respected theoretical physicists of the age. Sommerfeld's lectures were legendary, blending mathematical rigor with poetic vision. For Heisenberg, this was the spark he had been waiting for. Under Sommerfeld, he learned not only physics but the art of thinking. Sommerfeld treated his students as collaborators, not subordinates, encouraging them to question and create. It was there that Heisenberg began to see science as an exploration rather than a collection of facts. He learned to look beyond the equations, to feel the rhythm of nature within them. Sommerfeld often said that a true physicist must not only compute, but also listen to what nature is whispering through the formulas. Heisenberg absorbed this wisdom deeply, and it shaped his way of doing science forever. But his path was not always smooth. He struggled with the experimental side of physics. Laboratories, with their messy apparatus and unpredictable results, often frustrated him. He preferred the clarity of the mind's landscape, the realm of pure theory, where ideas could move without friction. Sommerfeld understood this and guided him toward theoretical work, recognizing in him the potential for abstract brilliance. During his university years, Heisenberg met other young physicists who would later become legends: Wolfgang Pauli, Pascual Jordan, and later, Niels Bohr. They were part of a new generation that would soon revolutionize science. The early 1920s were a golden yet uncertain time for physics. Einstein had already shaken the foundations of reality with relativity, and Planck had introduced the quantum hypothesis, but the nature of the atom remained mysterious. Heisenberg entered this world of half-understood ideas and contradictions. He was drawn to the puzzles no one could solve, the strange behavior of electrons, the unpredictable patterns of light and matter. Where others saw confusion, Heisenberg saw opportunity. His talent was not in following the known path, but in walking fearlessly into the unknown. During a summer seminar on Helgoland Island in 1925, he found himself working in isolation, suffering from allergies that forced him to retreat from the mainland. That solitude became the crucible of genius. With only a notebook, a few reference books, and the sound of the sea, he began rethinking the laws of atomic behavior from the ground up. He decided to discard what could not be observed and focus only on measurable quantities, frequencies, energies, transitions. It was a radical approach, born of both discipline and rebellion. He was no longer trying to describe what electrons were, but only what they did. That shift in thinking, away from physical pictures and toward mathematical relationships, was revolutionary. In that moment, on that island, the foundation of quantum mechanics began to take form. This boldness came from a lifetime of intellectual courage, from his childhood days of disassembling toys to his philosophical debates with mentors. Heisenberg had developed a pattern of thought that valued curiosity over conformity. He had learned that truth is not found by staring harder at the visible world, but by questioning the assumptions behind it. His upbringing in a scholarly household, where art, language, and science intertwined, had taught him that beauty and logic are not opposites. They are partners in the pursuit of meaning. His education under Sommerfeld refined that instinct, turning it into precision, and his exposure to figures like Bohr expanded it into philosophy. Bohr, in particular, would have a profound influence on Heisenberg's mind. Their relationship was one of mutual respect and constant challenge. Bohr's way of thinking was complementary to Heisenberg's. Where Heisenberg leaned on mathematics and abstraction, Bohr sought philosophical interpretation. Their conversations often stretched late into the night, full of paradoxes and possibilities. Bohr taught Heisenberg that uncertainty was not failure, but an inherent aspect of nature's design. This idea would later crystallize into the principle that bore Heisenberg's name. In the post-war years, as the young physicist matured, his early influences continued to echo in his work. The precision of Greek thought from his father, the harmony of mathematics from his teachers, the moral weight of a world recovering from war, all of these shaped his worldview. Heisenberg began to see physics not merely as a profession, but as a form of moral and philosophical inquiry. To understand the atom was, to him, to understand creation itself. He once reflected that nature is not a machine but a living conversation, one that reveals itself only when approached with humility. The academic path that led him to his breakthroughs was not driven by ambition alone, but by a quiet reverence for truth. Even as a young man, he showed a remarkable self-discipline. He would spend endless hours calculating, erasing, re-deriving equations, searching for patterns that others had missed. He was not satisfied until the mathematics felt right, until it resonated not just with numbers, but with intuition. That instinct for harmony was one of his greatest gifts. It allowed him to sense when an idea was incomplete, when a theory lacked balance. To Heisenberg, beauty was not a luxury, it was a measure of truth. By his mid-20s, Heisenberg had already become a central figure in the birth of modern quantum theory. Yet behind his success lay the echoes of his early life, the curiosity of the child, the precision of the scholar, the courage of the thinker unafraid of paradox. His education had not merely filled his mind, it had shaped his soul. The influence of his mentors and the intellectual climate of early 20th century Europe had forged a scientist who could bridge mathematics and philosophy, logic and mystery. In these formative years, Heisenberg learned a lesson that would guide him forever: that knowledge is not a fixed point but a horizon, always receding as one moves closer. His life up to that moment was a journey of pursuit, not possession, of questions rather than answers. And in that pursuit lay the essence of his genius. As Werner Heisenberg stepped deeper into his academic journey, the intellectual influences that had shaped him began to crystallize into a distinctive vision of science and reality. The lessons from his father, the discipline of his schooling, and the mentorship of great physicists like Arnold Sommerfeld and Niels Bohr all converged within him, forging a new kind of thinker, one who balanced mathematical logic with philosophical depth. By the early 1920s, Heisenberg was no longer a student merely absorbing knowledge, he was becoming one of the creators of a new scientific language, one that would rewrite humanity's understanding of the physical world. The foundations for his worldview were laid in his upbringing. His father had instilled in him the classical ideals of Greek philosophy, the search for harmony, proportion, and truth. These ideas, so deeply rooted in the study of ancient thought, became part of Heisenberg's intellectual DNA. He came to believe that nature, like art and music, possessed an inherent beauty that revealed itself through patterns and structure. Mathematics was, to him, the most precise form of art, a language that could describe the rhythms of creation. When he studied equations, he was not merely solving problems, he was listening to the music of the universe. This poetic sense of science would later become one of his trademarks, setting him apart from many of his contemporaries. At the University of Munich, Arnold Sommerfeld had recognized this unique blend of sensitivity and intellect. Sommerfeld's guidance was not just technical, it was philosophical. He trained his students to see equations as mirrors reflecting the laws of nature, to treat each calculation as a conversation with the cosmos. Under his influence, Heisenberg learned to balance imagination with rigor. Sommerfeld would often say, "The true physicist must be half artist, half mathematician." And in Heisenberg, this balance found its perfect form. The young physicist absorbed everything: mathematics, spectroscopy, atomic models. But more importantly, he learned how to think freely. Sommerfeld encouraged boldness, even rebellion against accepted theories, and that freedom gave Heisenberg the courage to question the very structure of reality. But Heisenberg's intellectual formation was not confined to Munich. His world expanded when he encountered Niels Bohr in Copenhagen. The meeting of these two minds would change the history of science. Bohr, the philosophical architect of atomic theory, became both mentor and intellectual sparring partner. Their discussions were intense, sometimes exhausting, but always illuminating. Bohr's approach was deeply philosophical. He believed that the act of measurement in physics was not merely observation but participation. Heisenberg, with his sharp mathematical instincts, found this idea both fascinating and troubling. Yet it resonated with his lifelong belief that truth was not static but dynamic, that reality revealed itself only through interaction. During his stays in Copenhagen, Heisenberg experienced the excitement and uncertainty of an intellectual revolution. The quantum world was full of mysteries that defied classical logic. Electrons behaved as both waves and particles. Light could act as energy or matter. The boundary between what was known and what was imagined grew thinner each day. These contradictions did not discourage Heisenberg, they inspired him. He felt that to truly understand nature, one must let go of old certainties. His philosophical grounding helped him see that the problem was not in nature itself, but in the limits of human perception. Bohr's influence deepened Heisenberg's appreciation for ambiguity. Together, they explored the idea that perhaps the universe did not offer absolute answers at all, that it might instead operate on probabilities, tendencies, and possibilities. This was a radical thought, but one that matched Heisenberg's inner understanding of the world. He had always sensed that truth lay not in the fixed but in the fluctuating, not in the definite but in the relational. Every conversation with Bohr seemed to bring him closer to expressing that intuition in mathematical form. Meanwhile, Heisenberg's personal character played a vital role in shaping his genius. He was known among peers for his intensity, his quiet determination, and his refusal to accept partial understanding. He had a deep sense of responsibility toward knowledge. Even as a young man, he often spoke of science as a moral endeavor, an act of devotion to truth itself. His studies were never purely mechanical, they were driven by an inner need to make sense of existence. This moral seriousness distinguished him from many others. It made him question not only what the universe was but why it was knowable at all. Heisenberg's early influences also included the music and literature that surrounded his upbringing. He played the piano with remarkable skill and often compared the structure of musical compositions to the laws of physics. To him, both followed invisible harmonies, patterns that transcended the senses. He once remarked that, in music, one feels the truth of harmony, and in physics, one seeks to describe it. This synthesis of art and science gave him an extraordinary sensitivity to patterns, an instinct that would later guide him through the abstract jungle of quantum equations. In the years following World War I, the German academic world was filled with tension and renewal. Old empires had fallen, but new ideas were rising from the ashes. Universities became hubs of innovation where young scientists like Heisenberg, Pauli, and Born questioned everything from the structure of the atom to the meaning of observation itself. These thinkers were restless, idealistic, and unafraid. They were building a new kind of physics, one that accepted paradox as part of truth. Heisenberg, with his blend of youthful energy and philosophical depth, emerged as one of the leading voices of this new generation. One of the most striking aspects of his education was his method of learning through contradiction. He thrived on intellectual struggle, on tension between opposing ideas. Rather than avoid paradox, he sought it. He would often describe his thoughts as oscillating between extremes, the mathematical and the mystical, the logical and the intuitive, until suddenly a new clarity would emerge. This mental rhythm mirrored the very nature of quantum mechanics itself, where opposites coexist and uncertainty defines the rules. It was as though his mind and the universe spoke the same language. By the mid-1920s, Heisenberg's intellectual development had reached its critical point. His experiences with Sommerfeld's mathematical precision, Bohr's philosophical vision, and his own artistic sensibilities all combined to create a unique worldview. He began to see the atom not as a small mechanical object, but as a symphony of relationships. He understood that to describe it, one must let go of classical images and instead rely on mathematical abstraction. This realization culminated in his groundbreaking work on matrix mechanics, a new formulation of quantum theory that dispensed with visual models altogether. The seed of this breakthrough lay in everything his early life had taught him: the Greek harmony of his father's teachings, the mathematical discipline of Sommerfeld, the philosophical depth of Bohr, and his own relentless search for coherence. It was as though every influence, every lesson, every conversation had been preparing him for this moment of insight. The boy who once took apart toys to see how they worked was now dismantling the universe itself, seeking to understand the machinery of creation not with tools, but with thought. Heisenberg's education was not simply an accumulation of knowledge, it was a transformation of perception. Through his mentors and experiences, he learned that reality is not something to be conquered, but something to be understood with humility. The boundaries of human knowledge, he realized, are not walls but horizons, ever expanding, never fixed. The early chapters of his life taught him that to truly grasp the universe, one must accept that knowledge and mystery coexist in a delicate balance. As the 1920s came to an end, Heisenberg had become one of the leading figures in a scientific revolution that was rewriting the very language of nature. But beneath the triumphs of equations and discoveries lay a deeper story, the story of a mind shaped by music, philosophy, war, and faith in reason. Heisenberg's early life was not merely a prelude to genius, it was the soil from which genius grew. From his childhood curiosity to his philosophical awakening, every influence, every mentor, every struggle had refined him into the man who would one day make certainty impossible. The same hunger for understanding that had driven the young boy in Werner to ask how things worked now drove the scientist to ask why they could not be known completely. His early years were not just preparation for science, they were the foundation of a worldview that united logic and wonder. In the quiet discipline of his youth and the turbulence of his times, Werner Heisenberg forged the tools with which he would uncover one of the greatest truths of the modern age, that uncertainty is not the enemy of knowledge, but its essence. His education did not simply teach him how to calculate, it taught him how to see, and through that vision, he would go on to reshape the boundaries of reality itself. The clash between classical physics and quantum theory was not merely a scientific debate, it was a revolution in human thought. For centuries, classical physics had built an image of the universe as a grand, predictable machine. From Newton's laws of motion to Maxwell's equations of electromagnetism, everything seemed governed by precise, unbreakable rules. The planets moved in perfect orbits, projectiles followed calculable paths, and every effect could be traced to a cause. It was a world of order, symmetry, and certainty, a cosmos that could, in theory, be completely understood if one only knew enough about its initial conditions. But in the early decades of the 20th century, this comforting illusion began to crumble. Beneath the surface of matter, at scales invisible to the human eye, the laws of classical physics no longer seemed to apply. Werner Heisenberg was among the first to confront this growing chaos head-on. As he explored the strange behavior of subatomic particles, he realized that the old equations simply could not explain what he observed. Electrons did not move like miniature planets orbiting a nucleus. Their motions were uncertain, unpredictable, and defined not by concrete paths but by probabilities. The more scientists tried to fix an electron's position, the more its velocity blurred into ambiguity. Nature, it seemed, refused to be pinned down. This was a direct challenge to the classical view of reality itself. Heisenberg's revolutionary insight that uncertainty was not a flaw in measurement, but a fundamental feature of nature, marked a turning point in science. This clash between the old and new ways of seeing reality was both intellectual and emotional. Many great minds of the time found the emerging quantum world deeply unsettling. Albert Einstein, who had helped spark the quantum revolution with his work on light quanta, could not accept a universe ruled by chance. God does not play dice, he declared, expressing his discomfort with the indeterminacy at the heart of Heisenberg's theory. On the other hand, Niels Bohr, Heisenberg's mentor, embraced the uncertainty as an essential truth about the limits of human knowledge. For Bohr, the act of observation itself changed what was being observed, a radical idea that further blurred the boundary between subject and object, between the observer and the observed. The debates between Bohr and Einstein became legendary, symbolizing the struggle between two visions of the universe, one seeking absolute determinism, the other accepting profound ambiguity. Heisenberg stood at the center of this storm. His formulation of matrix mechanics, a mathematical approach to quantum theory, was strange and abstract, lacking the visual simplicity of classical mechanics. Yet it worked. It predicted experimental results with astonishing accuracy. Even though it defied intuition, it forced physicists to abandon the comforting picture of particles as tiny, solid objects moving along definite paths. Instead, the quantum world became a realm of probabilities and possibilities, where reality itself seemed to flicker between potential states until measured or observed. This was not just a change in equations, it was a change in worldview. Classical physics had given humanity a sense of control, the belief that with enough knowledge, we could predict and master the universe. Quantum mechanics stripped away that illusion, replacing it with humility and awe. Heisenberg's uncertainty principle symbolized this new reality that our knowledge will always be limited, not because of faulty instruments or human error, but because the universe itself is built on uncertainty. The clash between classical and quantum physics also had a philosophical depth that extended beyond science. It forced thinkers to question the nature of truth, reality, and perception. Were particles real entities or mere mathematical abstractions? Did the universe exist independently of observation, or did observation bring it into being? These were not just scientific questions, they were existential ones. Heisenberg's ideas reached into the very heart of what it means to know something, to be certain, to define reality. In the years that followed, quantum mechanics triumphed over its classical rival in the laboratory. Experiments confirmed its predictions again and again, proving that the universe truly operates on principles that defy common sense. Yet even in victory, quantum physics left behind a haunting sense of mystery. The clash had not destroyed classical physics, it had redefined its limits. The macroscopic world of human experience still obeyed Newton's laws, but beneath that orderly surface lay a world of uncertainty, a quantum sea where particles dance to probabilities instead of deterministic rules. Heisenberg's contribution in bridging these worlds was monumental. He showed that uncertainty does not mean ignorance, but a deeper kind of knowledge, one that recognizes the universe's intrinsic complexity. His work did not destroy the foundation of classical physics, it expanded it into new dimensions, revealing that certainty is only one side of reality, and that true understanding lies in embracing both the known and the unknown. In the quiet corridors of physics, where equations hum like music and reality whispers its secrets, Heisenberg's voice still echoes, a reminder that the most profound discoveries are often born not from certainty, but from the courage to face uncertainty itself. Heisenberg's contribution to atomic and nuclear research was not limited to abstract theory. It extended into the very heart of physical reality, where the building blocks of matter reveal their deepest secrets. After his groundbreaking formulation of the uncertainty principle, Heisenberg turned his mind toward the structure of the atom and the forces that bind it together. The world was entering a new era, one in which understanding the atom meant understanding both creation and destruction. At the dawn of the 1930s, the atom was no longer seen as indivisible. It was a miniature universe of its own, a dense nucleus surrounded by a cloud of probabilities. Heisenberg sought to unravel the mysteries that lay within that nucleus, where protons and neutrons performed an invisible dance of unimaginable power. His work led to the development of quantum mechanics as a framework for describing atomic behavior in ways classical physics never could. While others like Schrödinger explored the wave nature of particles, Heisenberg continued refining his matrix mechanics, giving scientists a powerful tool to predict atomic transitions, spectral lines, and energy states. Each mathematical expression he derived represented a glimpse into the inner life of atoms. These weren't just equations, they were the coded language of the universe. Through his calculations, Heisenberg helped explain how electrons jump between energy levels, releasing or absorbing light in the process. This understanding was the foundation for modern spectroscopy, lasers, and even quantum computing decades later. When the neutron was discovered in 1932, the mysteries of the atomic nucleus deepened. Heisenberg immediately realized its significance. In 1932, he proposed a theoretical model of the nucleus, suggesting that it was made up of protons and neutrons held together by an exchange force, a kind of quantum glue that acted over extremely short distances. This was a revolutionary insight, forming the basis for nuclear physics as we know it. The Heisenberg exchange force became a crucial concept for understanding nuclear stability and reactions. His work revealed how the same forces that create the brilliance of stars could also, under human manipulation, unleash terrifying power. During this time, the boundaries between pure science and its potential applications began to blur. As Europe descended into turmoil, Heisenberg's research found itself caught in the shadow of politics. In Germany, his knowledge made him one of the most valuable physicists alive. When World War II began, Heisenberg became the head of Germany's nuclear research program. His mission was to explore the possibility of building an atomic reactor, and perhaps even an atomic bomb. Yet the details of his intentions remain shrouded in mystery. Some believe he deliberately slowed progress to prevent the creation of a weapon. Others argue that he lacked the means to succeed. What is certain is that Heisenberg found himself at the moral crossroads of science and war, torn between curiosity, patriotism, and conscience. After the war, when the world learned of the horrors of Hiroshima and Nagasaki, Heisenberg was haunted by what nuclear science had become. The very field he helped pioneer had been turned into an instrument of destruction. Yet, in his post-war reflections, Heisenberg emphasized the responsibility of the scientist to seek knowledge, not power. He saw the atomic bomb not as the triumph of science, but as a tragedy born of human ambition. To him, the true purpose of understanding the atom was to comprehend nature's unity, not to exploit it. His later years were spent working on a unified field theory, an attempt to bring all the fundamental forces of nature under one elegant framework. It was an effort to restore balance to a world that had lost its moral compass in the race for dominance. Heisenberg's contributions to atomic and nuclear physics reshaped not only science, but also humanity's relationship with nature. He showed that within the smallest particles lay the greatest mysteries and the greatest dangers. His theories paved the way for nuclear energy, medical imaging, and modern physics, yet they also served as a reminder of the fine line between discovery and destruction. In the silence of the laboratory, amid the glow of instruments and the hum of equations, Heisenberg glimpsed both the power and fragility of creation. His legacy in atomic research stands as a testament to the dual nature of human knowledge, that every breakthrough carries both light and shadow, and that the pursuit of truth demands not only intellect but wisdom. The moral and ethical dilemmas Heisenberg faced during World War II remain among the most debated aspects of his life. As the clouds of war gathered over Europe, science found itself drawn into the service of power. The same equations that described the mysteries of the atom could now be turned toward creating weapons capable of unimaginable devastation. For Werner Heisenberg, who had always viewed physics as a pursuit of beauty and truth, the war presented a profound conflict between knowledge and morality. Germany, his homeland, stood at the center of that conflict. When the Nazi regime came to power, many scientists fled the country, but Heisenberg chose to stay. Some believed it was loyalty, others saw it as non-vitae or even silent resistance. What is certain is that he stood at a moral crossroads that would define both his life and the role of science in the modern age. By the early 1940s, Heisenberg was appointed head of the German nuclear research program, often called the Uranium Project. The world's greatest scientific minds were racing to unlock the secrets of nuclear energy, each side hoping to gain a decisive advantage. In the United States, the Manhattan Project was moving rapidly toward the creation of an atomic bomb. In Germany, Heisenberg's team struggled with limited resources and internal conflict. He was faced with a haunting question. Should he pursue the bomb for his country, knowing what it could unleash, or should he restrain his work, using the guise of science to prevent catastrophe? History has never provided a definitive answer. Some historians argue that Heisenberg deliberately avoided building a functional reactor, slowing progress as an act of quiet resistance. Others claim he miscalculated, failing to understand the scale required to sustain a nuclear chain reaction. Whatever the truth, Heisenberg's conscience was burdened by the moral weight of his position. In 1941, he traveled to Copenhagen to meet his mentor and friend, Niels Bohr, who was living under Nazi occupation. Their conversation became one of the most mysterious encounters in scientific history. What Heisenberg said in that meeting has been the subject of endless interpretation. Some accounts suggest he sought Bohr's moral counsel, or even hinted that scientists should collectively refuse to build nuclear weapons. Others believe he was trying to gauge the Allies' progress or justify his role to himself. The meeting ended in tension, with Bohr leaving deeply disturbed. Their friendship, once one of the most profound partnerships in science, was fractured by the weight of war. Years later, Heisenberg would say that he had only wanted to protect the integrity of science, but Bohr never fully forgave him. When the war ended, Heisenberg and several German scientists were captured and held by the Allies at Farm Hall in England. There, hidden microphones recorded their conversations as news arrived that the Americans had dropped atomic bombs on Hiroshima and Nagasaki. The scientists were stunned. Heisenberg, upon hearing the news, reportedly sat in silence for a long time, then began to calculate how such a bomb could have been built. He had been beaten in the race for the atom, but more importantly, he was forced to confront what that race had cost humanity. His reaction was not one of envy, but of horror. The power he had once sought to understand had now been turned into a weapon of mass destruction. In the years that followed, Heisenberg reflected deeply on the relationship between science and morality. He spoke of the responsibility that comes with knowledge, warning against the unthinking pursuit of power. To him, science was not merely about discovering new truths, but understanding their consequences. He believed that the scientist's duty was not to serve politics or ideology, but to serve truth itself. Yet even as he expressed these convictions, critics continued to question his wartime choices. Was he a patriot trying to protect his country, or a scientist who failed to act against evil? The ambiguity of his actions mirrored the uncertainty at the heart of his own theories. Just as the position and momentum of a particle could not both be known, so too could the full truth of Heisenberg's intentions never be completely determined. In the aftermath of war, Heisenberg sought to rebuild both his reputation and his sense of purpose. He returned to Germany and became a leading voice for the peaceful use of nuclear energy. He helped found research institutes dedicated to pure science, education, and the advancement of knowledge without political interference. But beneath his public achievements lay the quiet burden of a man who had glimpsed both the creative and destructive sides of human genius. His life became a reflection of the eternal conflict between what can be done and what should be done. Heisenberg's moral dilemma remains timeless. It asks every generation of scientists the same haunting question: when knowledge grants you the power to change the world, how will you choose to use it? His story reminds us that science is not isolated from ethics, it is bound to it. Every equation carries consequences, and every discovery demands conscience. Werner Heisenberg's wartime journey is not merely a tale of physics and politics, but a mirror held up to humanity itself, showing that the greatest uncertainty of all lies not in the atom, but in the human heart. The lasting legacy of Werner Heisenberg's work extends far beyond the confines of physics. It touches philosophy, technology, and even the way humanity perceives reality itself. Heisenberg did not merely change science, he changed the very language with which we describe the universe. Before his time, knowledge was equated with certainty. The universe, it was believed, was a grand machine whose workings could be fully understood if one only knew the rules. Heisenberg shattered that illusion. His uncertainty principle revealed that the act of observing reality inevitably changes it, that nature is not a fixed stage but a living, shifting field of possibilities. This realization marked a turning point in modern thought, forcing humankind to accept that reality is not absolute, but deeply intertwined with our own limitations and perspectives. The implications of his work reached far beyond the laboratory. Philosophers began to see in Heisenberg's equations a reflection of human existence itself. The certainty humanity once sought in science mirrored the certainty people longed for in life: control, predictability, and order. But Heisenberg showed that beneath every apparent order lies uncertainty, an unresolvable mystery at the heart of being. His principle became a metaphor for the modern condition, that knowledge is always partial, that truth is never absolute, and that even the most brilliant minds must live with doubt. It was a humbling but liberating revelation, one that opened the door to new ways of thinking about science, consciousness, and the limits of reason. In the realm of physics, Heisenberg's influence continues to echo through every major discovery of the modern age. His ideas became the foundation upon which quantum mechanics was built, a framework that explains everything from the structure of atoms to the behavior of stars. Quantum theory, born from Heisenberg's insight, paved the way for technologies that define our world: transistors, lasers, semiconductors, and the vast field of quantum computing. Every smartphone, every satellite, every digital signal that travels across the globe carries within it a trace of Heisenberg's vision. Yet his true legacy lies not in the devices we build, but in the questions we continue to ask. His work reminded humanity that science is not merely about control or application. It is about wonder, humility, and the pursuit of understanding in a universe that forever eludes complete comprehension. As the 20th century unfolded, Heisenberg became a symbol of intellectual courage, a man who dared to challenge the foundations of knowledge itself. His uncertainty principle did not weaken science, it made it more honest. It stripped away the illusion of omniscience and replaced it with a profound respect for the complexity of nature. In a sense, Heisenberg brought science closer to philosophy and spirituality, uniting reason with all. He often spoke of the harmony between scientific truth and human intuition, seeing both as expressions of the same cosmic order. For him, the laws of physics were not cold equations, but windows into the divine patterns that underlie existence. In this way, his work bridged the gap between the measurable and the mysterious, between logic and imagination. Heisenberg's legacy also endures in the ethical dimension of science. His experiences during World War II taught him, and those who followed, that knowledge without conscience is dangerous. He became an advocate for the peaceful use of scientific discovery, warning that every new understanding of nature's power must be tempered by moral awareness. This lesson remains as relevant today as it was in his time. In an age of artificial intelligence, genetic engineering, and nuclear capability, Heisenberg's life reminds scientists and thinkers that the pursuit of knowledge carries an eternal responsibility. To use it for creation, not destruction. His story stands as both a triumph of intellect and a cautionary tale about the cost of forgetting our humanity in the pursuit of mastery. In his later years, Heisenberg sought unity, not just in physics but in thought itself. He dreamed of a theory that would bring together all the forces of nature, an elegant equation that could reveal the hidden order behind the apparent chaos. Though he never achieved this final synthesis, his search inspired generations of physicists who still chase that vision today. The quest for a unified theory, the theory of everything, remains one of science's greatest frontiers, and it began with the questions Heisenberg dared to ask. His influence persists in every physicist who looks at the world and wonders what lies beyond the limits of measurement and certainty. When Heisenberg died in 1976, he left behind not just a body of scientific work but a philosophy of understanding. His uncertainty principle became more than a formula, it became a worldview. It taught that doubt is not the enemy of truth but its companion, that every answer opens the door to deeper mysteries. In this sense, Heisenberg's greatest gift to humanity was not knowledge itself, but a new attitude toward it, the courage to live within uncertainty, to find meaning in the unknown, and to see in the smallest particles the infinite depth of the cosmos. Today, every time a scientist peers into the quantum world, they stand in Heisenberg's shadow. Every discussion about consciousness, probability, or the limits of knowledge carries traces of his thought. He showed that reality is not static but participatory, that we are not mere observers but part of the unfolding universe itself. In the end, Heisenberg's legacy is not about making certainty impossible, it is about revealing that uncertainty is the truest form of wonder. His life and work remind us that in the heart of the unknown lies the beauty of discovery, and that even in the depths of uncertainty, the human spirit continues to seek, to question, and to understand.